Okay. Hey everybody, welcome back. So I have changed my broadcast settings to match what it says on the Twitch website, and hopefully that fixes any of the issues we were having before with, well, anything. It says right now that I have an excellent connection, no recommended changes, so that is probably a good thing. So where we left off was we had gotten our board all built up, and we were basically stealing some scripts from online to make sure this worked well. But we're not having any luck at the moment. Line 60 is what is boning us at the moment. So line 60, which is calculate vec xx equals calc or calvec xx over size, unsupported option type for s equals list and int. So let's go to line 60, see what we're doing here. Line 60 is in this thing here. So we have our normal pixel. Let's see. So while 1, so while true, we're trying this, calibrating the sensor. Sensor should have a clear path to calibrate against environment. Okay. And then it's reading the sensor pixel data. And it's saying if KK is greater than cal size, calibration size plus 1, which I don't. Okay, so calibration size is 10. And what is KK? KK is 0. So if KK equals 0, we're calibrating it. And if it's that, then we're getting this. So if KK is less than cal size plus 1, we're going to KK plus 1. Then if KK equals 1, we are going to calvec equals normal and continue. Else if KK equals cal size, so once we get to 10, we are going to 4xx in range len normal pixel. So for the length of normal pixel, calvec xx equals normal pixel, so that, okay. And it looks like what's happening is we're not getting our data in here properly. I think it's reading everything not the right way. So here's what we're going to do. First and foremost, what we're going to do is let's copy this. I think we have a secondary method in here called temperature. We do. And I'm just going to see, I'm curious what this prints out. So we're going to print norm pix, and we're going to copy this. We're going to just do it here too. And let's just see what this does. It's going to break, but when it breaks, we are going to see 2 different data streams. Okay. So they actually came out the same way. That's good. I think what's happening here is this is expecting one full length. I think it's just expecting the pixels without any of the array information here. So I'm going to just do this. Let's create a NumPy array. I don't think we have NumPy imported in here, but we might. Let's see. Import NumPy. We do have. Okay, we have NumPy. We're gonna create an empty array. Just bear with me here. So np dot zeros. We're going to call this normal pix. So norm pix equals numpy zeros. And field we're looking at. Same thing. Okay, so we're just going to type in zeros. So what this is going to do is this is going to just create an empty data array. Okay, so we got an example here. That's just going to create 5, and we have 64. So let's see what happens if we just do this. So let's just do 64. Let's see what happens if we run this. Okay, so it's doing what I think it's supposed to be doing, but for some reason we're not generating an image. I'm not sure why it's not plotting this, because it should just be giving us a blank image, but I'm not seeing the blank image. So let's see where this is coming from. So that's going through there, and then moving pixel plot. Okay, so what we're printing is this. We're reshaping it. Now, why is plot draw? Why are we not seeing a plot show? I feel like we should be. I feel like there should be a show in here. So let me see. So plt dot show. I feel like we need that. Turn it on. All right, so I'm looking here. It says plot draw. Okay, so we should have plt.imShow. So where is that in my code? Oh, it's right here. So the question is, why is it not showing up? It might be because of this. So let's just check that out. Come on, do the thing. I mean, we're getting data here, but for some reason we're not seeing the. Oh, wait, there was something over here, maybe. Let's see. It looked like something flashed on the side of our screen. No. Do we have anything loading? No. Okay, so I really hate Matplotlib. Let's see if OpenCV installed. See, OpenCV didn't install. We're going to try and install OpenCV again. So give me a second here. I'm importing the OpenCV package. And it's doing something. So let's see. Installing build dependencies. It has started. Wish we had some type of way of seeing what it was doing. Do we? No. Okay. I don't know why it freaked out like that, but it did. So right now what it's doing is it is downloading OpenCV and installing OpenCV into this project. And we're going to replace any of the matplotlib plot stuff with OpenCV, and we're going to change this code up to show us what's going on in OpenCV instead. And we're also going to simplify this a lot. So let's turn off. We're going to get rid of this calibration procedure because we don't need the calibration. I just want to show my raw pixels here. So, I do like that this reshape thing is reshaping our data. So normal, norm, pix, so this should be image equals that. And if we print image, we should basically just see a bunch of zeros every time this refreshes. So let's see if we broke it completely. Oh, right, because we don't have any module called CV2. So until that gets installed, that's not going to work. So let's see. It should just give me a bunch of zeros. Yeah, it does. Okay. So now what we're going to do is we need to make it so that the center pixels thing spits out the right data. So let's take a look at this. Let's dive into it. So pix print norm pix. So what we should do now is we should get an array to start that has the data. Yeah, there we go. And we want to turn it into these. So for some reason, okay, so let's take a look at this. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's interesting. What we really want to do is be able to restructure this object into a NumPy array. So we want to take a list to NumPy. Let's see, convert a list to NumPy array. This might be way easier than I think it is. Using NumPy array. So we're going to try this. Let's just turn this off. And we are going to say normpix equals np dot array dot normpix. Let's see. Is this gonna bonus, or is this gonna let's see what happens here. Hey, look at that. It actually worked. So first I'm going to kill this. So let's stop displaying that. And we're going to actually condense this down into one line of code. So let's just say that normpix equals this Okay, and we're going to just delete these. Okay, delete. What does it look like? Do we actually need to reshape it, or can we just print it how it is? So let's take a look. These. So let's print norm pics. So if I print norm pics and we print img, they should be the same thing. We're going to see. So we shouldn't have to reshape this data. So that and that, they are the same thing. Okay, so we can also get rid of this. And it looks like we're still installing OpenCV. Still running PEP 51. I feel like we're having an issue here, so let's try this. Let's see, ls. Let's pip reinstall OpenCV, or we're gonna search for it. Okay, so we have an issue here. What's going on here? Pip or PYP PI is pissed off. So let's uninstall that. What are our options? I always forget. So pip3. Okay, let's uninstall. So pip3 uninstall pypi. Okay, it's pypl. Let's see if this fixes everything. Okay, so that successfully installed that. What's going on here? Why are you all pissed off? PYPI. What is PYPI? Well, I guess we're going to search. So P oh, we're indexing. That's what it is. Okay, so we're going to go back in here. You can't see it. I'm going to settings, and it doesn't look like OpenCV is installed. Okay, so we're going to try this one more time. OpenCV, and it is called OpenCV Python. So let's try that in this command line here. And there's also, yeah. I didn't want to search, I wanted to install. And I like doing this way so I can actually see what's happening here. Okay, so it is collecting the resources. And it is installing build dependencies. You can see that here. Building wheel for OpenCV PEP517. I feel like that's where it was getting stuck. So just in the meantime, let's see what it's doing here. PEP517. Building wheel. I wrote building win. Looks like people have had this issue. Builder stuck on building wheel for NumPy. Yeah, I really wish there was. Okay, so you know what? We're now that we have some of these libraries figured out, we're gonna just do this the old-fashioned way. I really hate these virtual environments that it builds in PyCharm because sometimes it gets pissed off like this. So what we're gonna do is we're going to do this. We're gonna sudo apt search open cv, and this is going to show me the repos that exist. And here we go. I like this one, so we're going to do this. Oh, that's already installed. Look at that. Okay, so we are going to switch this compiler over to our local compiler on the system, which means that we're probably going to break a few of these libraries because they're not globally installed. So let's just see what happens. Yeah. Also, we can remove this and this. We also need to have OpenCV2 install running. We can remove that. So let's try this again. Yeah, plot is not defined. It's fine. So here we go. That's running. Okay, so now we are going to do this. We're going to just put, we're going to do try cv2.show. We're going to call you thermal. IAM show. And we're going to need a wait. So, right, this needs to go down here. And then we need to put normal picks in there. And we are going to need, so let's do open CV, display video, image. Of course, I got the, believe this is, you know, we got the C++ version. I want Python. There we go. Okay. I'm not going to use OpenCV display most recent. Yeah, well, this looks good enough. We can close that. 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 And that. Okay. Yep, that'll do it. All right, so let's see what happens here. Might work, might break. Okay, so it's kind of working, except for the fact that our data is very small. So what we are going to do now is we're going to try this. We are going to take our normal pixel. We are going to do this. We're going to do norm pix equals cv2.scale. Scale or resize? Let's look that one up too. So we have cv2 resize image. It's resized, okay. The source is going to be normal pixel, and destination size is 512 by 512. And let's see what this does. It might explode or it might work. Okay. So now, you're not seeing it, but we have a big white screen, which is our output. And I'm going to see if I can figure out a way to show that. Before we do that, I'm actually going to check out and figure out a way to change this. Okay, so what we want to do, because right now we're only getting these values, and they're not working, because I believe it wants, for grayscale values, it wants something between 0 and 1. So I'm going to see something. I want to see what happens if I just divide this NumPy array by 100. This is just an experiment. I don't know what's going to happen here. Assuming these numbers are going to be smaller. They are. Okay. So what we're going to do here is I'm going to take this, put it down here, just so you can see what this is doing to our array. So we're going to play that again. And now we have numbers that are below 100, sorry, below 1. And we are just doing that. So what I'm going to do now is I'm going to apply a matte, basically a color to this thing. So it's OpenCV color where it's called color map. That's it. Okay, so we're going to color map this data. So I'm going to try searching this a little differently. So color map, so OpenCV, color map, Python. Okay. Apply color map. This is exactly what we're looking for here. Okay. So, okay, so we can apply this in here. So what we're going to do before we scale it, we're going to apply the color map because it's easier to apply that to a smaller file. So we are going to call this IM color equals cv2 dot apply color map. And we're taking norm pix, and we are going to do cv2 dot color map jet, and we're going to change this up. So what we're feeding into here is IM color. IM stands for image map. Okay, so now, so we can do this right, we should have a color image coming out of our I fucked it up. So it only supports integers. Okay, it's fine. So let me see. So how do I turn these into integers? NumPy array to int. Okay, so we are going to do this. Let's just do this. So is that going to do it, or is that going to just break? Yeah, that didn't do it. Okay, so what that means we need to do is, instead of dividing this by 100, let's take this. Let's do norm pix equals numpy dot as type int. Okay, so that did work, but it only works with 8-bit color 8UC. Okay, so let's do this. Let's see. NumPy array to 8UC1. Oh, I did 8UC2. I change a NumPy into a grayscale. Let's try this. Hey. Starting to work. Not quite there. So let's see. Pardon me. Oh, the other thing we can do here is try this. Okay, so let's try this. Getting closer. Okay. So let's see what our output here from NormPix is before we turn it into this grayscale image. So let's multiply this by 10. This might break everything, might not. Well, that was unexpected. That's not what I expected to be getting as my output array here. Well, that's because I am outputting the same thing. Okay. All right. So I don't want to turn this in. I want to see if I can turn this into a float. So let's do numpy array to float. Is it float 32? Is that what it is? Yeah, okay, so we want to do this to np float 32. Okay, so this should give me a decimal output. It does. And the error is on apply color map. Okay, so let's do this. So let's go back to what we had here. We had uint 8. And what was our problem? Our problem is the number is not the right thing. We're not seeing anything. We're just seeing this blue. So what if I get rid of this color map? It's going to break that. That's fine. Let's see if this looks like it's grayscale now. So this should be gray image. On screen we should see something that is gray, black. Getting any data? We are. Okay. So that means we need to normalize this data. So we need to. So what's happening is it's too close. So let's see. Adaptive thresholding. So what is that going to do? Let's do this. So OpenCV, normalize. Okay, so what this should do So what I'm doing now is I'm looking up normalization using histogram. No, let's just do basic normalization. Normalize Python. This should be pretty easy. Okay, so we're going to put that here. we're gonna see if this totally breaks everything. I don't think it will. I think we're actually gonna have some decent results. Nope. Because we are just outputting zeros. Okay. But we are getting way closer. Probably should read the documentation on how OpenCV normalize works. Instead of just pressing random buttons. This documentation is 4. Ah. Getting something. Okay. So now I should be able to change the color of this thing to jet map. Okay. Almost getting there. Okay, so we're gonna actually change this to IM color. Okay, so let's go to CV normalize. I think that's what this is. Okay, so CV. Normalize. Okay, so input array, output array, double, alpha, beta, normal, distribution. Okay. So normalize values of an array. Okay, so alpha is a normal value to normalize the lower range boundary in case of the range normalization, and the upper range boundary. So it should be 0 and right. This should do it. What's up with this norm L1? So norm L1 is normalization types. Let's just try norm inf. And this should pull our data to the top and bottom of our range. Which means it should be creating a contrast in our data. let's just print this out. So let's print what our data is before denormalization, or after normalization, and before normalization. Okay, so before normalization, 17, 16, okay. And after it, it's 30. Okay, so I don't understand why it's not normalizing it between 0 and 255. We're also not using this convert to color, so maybe that is an issue. Print. Let's see what the data is in this print in this. Okay. So in there, what it's doing is it is turning it into a color matrix. So I do like that. So what we're going to do is we're going to take that and move that down here. And that is what we're going to apply this color transform to, because that's what this really wants. So we're going to, actually it really doesn't matter. It doesn't matter. We're not going to deal with that. Okay, but I do want this to normalize it properly. So we're going to try norm min max. Let's see what that does. So I don't understand why this is not outputting my data the way that I'm expecting it to be, normalizing it. We're gonna try it this other way. The second variable being the output. And see what happens. Yeah, IM color is not defined. I thought that might happen. So what we're going to do is we're going to do this. We're going to just call this IM color, and it's going to be 8 by 8. Hey, look at that. Okay, so now we actually have something that's working. What I'm going to do now is make it so you can see my screen, so you can see the thermal output, because we actually have an output. Actually, before I do that, I'm going to just quickly kill these print methods because I don't like them. So, also this wait key is way too long. So let's get rid of this, and we're going to get rid of this, and I'm going to run this, and I'm going to open up opens. So we're going to open up that. All right, so now let me add this to my output, and we're going to add thermal, and this is what my thermal sensor is seeing. So if I hand over it, well, it's upside down. So let's just flip that around. Oh, and it's still freaking out. It needs to be flipped horizontally now. Oh, that's funny because it's actually looking up, and I'm looking at the down camera. So, so that's the problem. Is if we wanted to have this matching up with our camera that is above us, I'd have to actually take this thing and mount it up like that, and we'd have a hand. I think what you're looking at is my mouse. That's probably the heat signature there. So the next step on this is going to be taking this and mounting it next to our camera above, so that we can actually get some type of, semblance between the two things. I think this is probably as fast as this thing is going to update because it is only a 10 hertz sensor, but we can check that in our code just to make sure we are running this as fast as we possibly can. Also, there's a bunch of variables in here that we don't need. Let's kill those. This is waiting for it to boot. That's fine. What else in here we don't need? Kill you. We can get rid of that. We have CD2 in here twice. No? Okay. Alright, so let's take this. Okay, it looks like also okay, so let's change our normalizations here. Let's go back to, let's try inf again, see what that does. Nope, well that's pissed, so we don't like that. So let's take a look at what min-max does to our data stream. All right, so min-max really is pushing that to the up and bottom limits of our data. Let me bring that back on screen. Do we see that again? Yeah. Okay, so that is the up and bottom of our data, and that is a wait key of 1. Can I put in a wait key of 0? I always forget. So we're gonna kill this and see what happens if we put a wait key of 0. I may have just pissed it off, but we're gonna see. Yeah, it's frozen now, I believe. Yeah, wait key of 0 freezes it. Can I do a wait key of 0.1? Let's see. Nope, it expected an integer. Okay, so that's 1. Okay. So that looks like it is the fastest this thing is going to give us data. That's pretty good. All right, so here is the final code. Take a look. The final code to make this thing, let's just go and review, is the first thing we are going to do. Well, first thing we're going to do here, let's get all the way up to here. All right, so because we are not using a Raspberry Pi and we're not using something that has a built-in I2C, we have to use this little board, which is our FT232H from Adafruit. It is a multi-protocol USB I2C, SPI, and GPIO input-output board. And we want to connect up this AMG8833 thermal sensor. So in our code, what we had to do was first we bring in sys, we bring in OS path, we let this do its thing. We have from time, we imported sleep, we had import numpy as np, we have import cv2, which is opencv2, we have import os. What we're doing here is we are setting an environment variable, which is blinka underscore FT232H, and that is set to 1. And what that is doing is that is allowing our system to actually access this chip. Next thing we're doing is importing bus IO, and we are importing board, and we then are importing Adafruit AMG88XX, and then we are importing FTDI, but from that we're importing pi FTDI.FTDI, and we are importing FTDI from that. And then what we're doing is we first are identifying that our system is working. So what we're doing is we are opening FTDI open from URL, and that is FTDI equals / FTDI colon 232H:1/1. Then what we are doing from there is we are assigning our I2C bus, and what we are saying that is bus io.I2C board.scl board.sda. So what that's doing is that is assigning our pins from our board here. And what we had to do on this board to make sure that it worked with SDA and I2C is we had to connect up our voltage through our 3 volt. We have our ground, which is connected to our ground. And then in order to get the SCL to work, we had to, well, first connect that up to the SCL, which is our clock. And then for SDA, which is our data, that had to be a combination of the MISO and the MOSI port on this chip. So those two connected had to daisy chain into one row to give us our input-output, and that is muxed once it gets to that chip. So that is where we are defining what is the SCL and the SDA. That is the SCL and the SDA. Then what we do is we are initiating the Adafruit library for the AMG88XX. We're bringing in AMG XX, and we are telling it to access that on these 2 ports, and we're calling that sensor. Then what we do the first time we run this code is we sleep for a millisecond, and millisecond. And we let the board come on, and then we are pre-allocating the matrix called norm pix, and that's just a list here. And then we start with a try. And while 1, so while 1 is also the equivalent of while true, what we're doing is we are assigning normal pix equals numpy array sensor.pixels dtype equals numpy unint 8, and unint means unsigned integer, so there is no plus or minus on the integer. And then just to break this down a little further, what sensor.pixels is doing is reading from the board the integer that reflects the pixels coming in. Then what we're doing is we are creating a blank numpy array called imcolor, and this is numpy 0, so it's making an 8x8 array of zeros, and those are unassigned integers as well that are 8-bit. Then what we are doing is we are applying a normalization to our data set, and the normalization is taking the input of what's coming out of the sensor, and it is putting it into this IM color, and what it's doing is it is pulling the data from the top and bottom of the pixel values, and it's making the lowest value equal 0 and the highest value equal 255. From there, what we're doing is we are printing that, which you are seeing right here on the in the terminal output. And from there, what we are doing is then applying what is called a color map in OpenCV. And the color map basically just turns the black and white information into color information. So this looks prettier than just looking at a grayscale. Then from there, what we are doing is we are resizing this because our original data set is actually only 8x8, which would show up really small on the screen. So we are actually turning it into something that is larger than 8x8 so that we can see what's going on. Looks like I just realized we have some feedback going on this crazy video. Doesn't matter. So 8x8, we turn it into 512 by 512, so it runs and we can see what's happening. And that's what we're doing here. We're resizing it. And then we have this line of code, cv2.im show thermal normal pix. It's taking this input, putting it here, naming it thermal, which you can actually you can't see, but the name of the window that the data is in is called thermal. Then we have k equals cv wait key. So this is just needed for the loop that is in OpenCV. And then from there, we have if k equals 27, which equals the escape key, we break this loop. On the exception, it says that the Control-C program stopped to be a keyboard input. And then finally, exiting loop. This is if we have an exception. And then finally, it says exiting loop. So if I were to bring this down to the bottom of here, and I press escape, look at that. Exiting loop, and we are done. So that was fun. The next step in this project is going to be twofold. One is mounting this little thing inside of a little box and also wiring it up with some vinyl wires so that we don't have to be using our project board or our what's it called, our breadboard and these testing cables. And then the second step after that is figuring out an efficient way to get this to run inside of OBS. There are two things I'm thinking. I mean, the easiest way that we have here is we're just screen capturing. But, drawing on the screen and having to deal with that is not the most efficient way to do this. What I would like to do is possibly enable MJPEG streaming and create a little web server that is streaming out the data as MJPEG and allow OBS to import that as a video stream and go with it there. But ultimately, the best way to do this would be to be able to create a virtual V4L input device. So it makes pretend that it is a webcam coming in and just sees it as another webcam device in OBS. That would also be really cool because it would let me stream that out to any other platform like a webcam. So basically it's building a Python script that when you run it, it's basically a driver. So thanks for tuning in. I'm going to sign off now, and later tonight I might come back and either work on this project or get back to work on our PPECom. So if you like what you see, please subscribe. If you haven't subscribed, if you have any questions, please feel free to message me. Thanks for tuning in, and catch you later.